So in this third video of trigonometry, we're going to go through how to solve basic trig equations. So in this particular video, I'm going to go through what the trig graphs are, how we use them to solve trig equations. So before we continue with this video, what we need to do is make sure you know a couple of things. So the first thing you need to know is the shapes of y equals sin x, y equals cos x, and y equals tan x. And if you're not too sure, we'll go through those graphs in a sec. How to sketch these graphs, noting the intersection points of the y and x axis in each for each equation with ranges of minus 360 to positive 360. How to use the inverse function on your calculator, and if you've got access to a graphic calculator, how to plot equations, how to change the scales of axes, and how to find values of intersection points. So the first thing we can look at here, this is the sin x graph from minus 360 to 360. So as you can see, the general shape of the sin x graph is that it forms a helix, and one of the key things is that it starts at 0. So it has a period of 0 to 360, and then obviously it then repeats itself from there on in. And obviously the range of y values you can get is positive 1 to minus 1. Moving on to y equals cos x. Now y equals cos x is very similar graph to y equals sin x. However, it has a different starting point. So with y equals cos x, it starts from the origin, it starts at 1. And then obviously it continues to have a period of 360. And again, the range of values you can have for y equals cos x is 1 to minus 1. And then we move on to y equals tan x. Now y equals tan x follows a completely different shape of graph. Now as you can see that it starts at the origin and goes through the origin, and then now the difference between y equals tan x is that the range of y values goes all the way to infinity and minus infinity. So as you can see on this graph, it only goes from 0 to 6, but that line does continue all the way up. Now you might find that might question why there are red dashed lines going up. Now the reason for that is when you type in the values of y equals when tan x equals 90 or tan x equals 270, you'll find that your calculator will either come up with a math error or a syntax error, and the reason for that is because that curve goes all the way to infinity. So if you were to type in, let's say, 89. Tan x inverse tan of 89.999 recurring, your calculator might come up with a syntax error, or it might give you a ridiculously large number. So the closer your inverse tan value is to, let's say, 90 or 270, or respective minus 270 to minus 90, the value on your calculator will be an extremely large number. And likewise, if you've typed in a number that was just over 90 degrees, again it would give you a rather large negative number. And what we call that is the fact that the tan graph is asymptotic to 90, 270 and minus 90 and 270. So the fact that that line will never ever become that value, it just gets ridiculously close to it. So what we're going to do here is just go through my 5 steps of answering these types of equations. So we'll go through some examples, and I'll go through where these 5 steps and what these 5 steps mean. So the first step you want to do is always draw a sketch of the trig graph with the requested x scale. So in a trig equation question, they'll always recommend to you what scale to use, whether it be 0 to 360, 0 to 180, minus 180 to 80, etc. So in the equation, you want to make either cos x, sin x, tan x the subject. Now in very easy questions will start off, that will always be the case, but when we move on to in the next video with regards to complex trig equations, I'll show you how that's not the case. So once you've made sin x, tan x or cos x your subject, what you then want to do is mark on the graph a horizontal line through this value. Then the third step is that you want to use the inverse function on your calculator to solve for x, and this will be the closest angle to the origin of your first solution for that equation. And then on your graph, what you then want to do is mark that angle on your graph. And then step 5, and the last final step, is then to use this value and the graph to find all the other respective values within the given range. So let's put that method into practice by going through some examples. So in these examples, we're just going to start off where all the equations have got cos x, sin x or tan x as the subject. For more complex equations you might find that you might have to do some rearranging. However, with these questions we're just going to go through the very basics and how we use the graph to answer those questions. So for the first set of questions we're just going to focus on the cos graph, and as you can see I've already pre-drawn my cos x graph. Now I've kind of extended the graph from -180 to 360, and obviously it's worth always paying attention by reading the question carefully and noting what the range is. So for these set of questions we're only looking for ranges between -180 to 180. So anything beyond this here is going to be absolutely useless. So I'm just looking at this range here. So looking at first things first, what we need to do is, now that we know that cos x is the subject, it's always worth paying attention, and we know that that is equal to 0.8. So what I'm going to do is I'm going to draw a horizontal line through what I would say is roughly 0.8. Now obviously it should be using a ruler, but again it's just a sketch and it's just to kind of help me. Now in terms of where the intersection points are for where it's 0.8, I would say at a guess, looking at my graph, I'm looking for a value that is going to be close to -145, -45 rather, and under +45. So that's the two values that I'm looking for. Now what I now need to do is use my calculator to work this out. So if I do x equals the inverse cos of 0.8 and I type that into my calculator, the value that I get is going to be 36.869, and that continues. So rounded up it's going to give me x equals 36.9. Now your scientific calculator will only give you one of the angles, not all of the angles, and it'll probably give one that's closest to the origin. So I know that this distance here is 36.9 degrees, and that's because it starts at the origin to my first point. Now to find the second point, which is on the negative side, so this is the second point and this is my first point, all I need to do there, so to find the second point I just need to do 0 minus 36.9, which is just going to give me minus 36.9. So there I have found my two solutions. So to find the first angle we use the calculator. To find the second value I then need to use the graph and then decide whether to add or subtract and from what value. So moving on to the second part, so if I change colour, different colour pen. So here we've got cos x equals -1/3. So again, your answers would either be in the form of a decimal or a fraction. So again, first double check, make sure that we've got cos x as the subject, which we have, and then we've got -1/3, which is basically minus 0.3 recurring. So if I was to draw another horizontal line, which is pretty poor there, which I would assume is -1/3, as you can see I'm looking for two values within that range of -180 and +180. And looking at this point here, I can see that that is a value that's going to give me, that should be more than 90 and less than 180, and this second point is going to be less than -90 but more than -180. So what I'm going to do to find my first value, I need to use my calculator. So I'm going to do the inverse cos of -1/3 on my calculator, and if I quickly do that, I get a value of 109.471, and that continues. So that's my first angle to one decimal point, that's 0.9.5, which again looks about right. So 109.5 is that first angle, and as you can see, so the distance from the origin to that point is 109.5. So then to find the second value, again that is also going to have a distance of 109.5 from the origin. So the second angle is going to be 0 minus 109.5, which is minus 109.5, and lo and behold I've got my two angles. Now what is probably good practice is for you to write down the angles that you found within the given range as separate answers. So for example, all I'm doing here is writing down so that the examiner or whoever's marking your work, the teacher, doesn't have to shop around or doesn't have to look around and just find your answers. It's written neatly right at the bottom of your solutions. So in the second set of examples, what we're going to do is we're going to have a look at equations involving sine. So what I've done here is I've drawn the sin x graph from the range that we've got in the question, which is changed from minus 360 to positive 360. And in this, what we're solving is, in the first one, we're solving sin x equals 4/7. Now, as we've got sin x the subject, I can go straight on to drawing a horizontal line through y equals 4/7. So this blue line here represents 4/7. Now, as you can see from the graph, from the red line to the blue line, we have got 4 intersection points of what I actually need to find. So there's the 4. And so what I'm going to do is I'm going to use the calculator now to find out my first point. So x is going to equal the inverse sine of 4/7, and typing that into my calculator. So looking at the first angle that's closest to the origin, I'm looking for a value that's between 0 and 90. So if I type in inverse sine of 4/7 on my calculator, I get 34.849, so 34.8499, and that continues. So if I just round that up to 34.8, I found my first angle. So basically what this is telling me is that this distance here is 34.8. And so now what I'm going to do is I'm now going to use that angle to now find my other angle. So starting with this next positive angle that I've got to find. Now, from the origin, the graph of y equals sin x starts at 0. So I need to look at the next point, or the next closest point of where it starts at 0 again, which is at 180. And so basically what this is telling me is that this distance from my second point is going to be 34.8 away from 180. So my second angle is going to be 180 minus 34.8, and if I type that into my calculator, I get an answer of 145.2 degrees. Now, to work out the two negative angles that I've got, which are here and here, so if I just label this as my third one, this here as my fourth angle, that was my first, and that was my second. So just label the answers that I've got here. So to find the third angle, so again I'm looking for the closest point to when it was at 0, which is at minus 180, and it tells me that this distance from minus 180 is again 34.8. So for this, to find the third angle, all I need to do is minus 180 minus 34.8, and I type that into my calculator, which gives me an answer of minus 214.8 degrees. And then to find the fourth angle, again I'm looking at the nearest point to it from when it's 0, which is at 360, and what it tells me is that this distance here is 34.8. So I'm going to do minus 360 plus 34.8, because I want the right hand side of that. So I do minus 360 plus 34.8, which gives me an answer of minus 325.2 degrees. So as you can see, I've now found my 4 intersection points of y equals sin x and y equals 4/7. So what I'm going to do now is just write down the answer a little bit neater to how examiners will find it easier for me to follow. And let's go in terms of size order. So we go minus 325.2. We've got minus 214.8, and I've then got 34.8 and 145.2. And there are those 4 angles. So moving on to question B. So here we've got sin x equals minus 0.424. So again, I'm going to draw, as we've got y equals sin x, I'm now going to draw a horizontal line through minus 0.424, which I'm running out of space, so let's just do it over here. So this is minus 0.424, and as you can see from this, I've got one interception point there, another interception point there, another interception point there, and another interception point here. So looking at this, the first angle that's closest to the origin is this one here, so I'm going to label that as #1, because when I then reach for my calculator and I look to solve this by typing inverse sine of minus 0.424, my calculator is going to give me minus 0.424. It's giving me an angle of minus 25.087, and that continues. So I'm just going to round that up to minus 25.1. So what this is basically telling me is that this angle here is minus 25.1. So from its original starting point from the origin, that this little distance here is 25.1. So to find the second angle, so let's just say this one is my second angle. So that is going to be minus 180 plus 25.1. So if I type that into my calculator, minus 180 plus 25.1. So with this, and the help of the graph is for you to decide whether you add or subtract. So if you just use your common sense, like if I was to take it away, then my angle would be here, but if I'm adding it, then my angle would be where I'm wanting it. So minus 180 plus 25.1 is minus 154.9 degrees. Then to find this angle here, again starting from when it's the next time it's 0, which is at 180, I'm going in the right direction. So this distance here is going to be 25.1. So I'm going to do 180. So this is the third angle, 180 plus 25.1. And again, just to be sure, type that into your calculator, and we get 205.1 degrees. And then to find the fourth angle, as you can see, it's on the left of 360, which is the next time it's 0. So this distance here is 25.1. So I'm going to do 360 minus 25.1. So 360 minus 25.1 gives me an answer of 334.9 degrees. So all I need to do now is write up the final answer, so it's nice and neat, so for anyone who's marking it. So here x is going to equal minus 154.9 degrees minus 25.1 degrees, 205.1 degrees, and 334.9 degrees. So now moving on to the tan equation. So again, following the same sort of format. So what I've pre-drawn is I've drawn the tan graph. As we've got tan x as subject, I've drawn a horizontal line, a horizontal line through 2.5, which is here. And so now what I'm going to do is go about and solve it. So for the first one, we've got x equals inverse tan of 2.5. And if I reach my calculator and I type that in, it will give me my first angle, which in this case, x equals 68.198, and that continues. So let's round that up to 68.2 degrees. Now, from this first angle, so this tells me that this angle here, or the distance from the origin, is 68.2 degrees. So to find the second angle, which is here, so this is my first angle and this is my second angle. So to find this, I'm looking for the next time it's 0, which is at 180, and that distance there is going to be 68.2. So to find the second angle, I just need to do 180 plus 68.2 plus 68.2, and we get an answer of 248.2 degrees. Now, one thing that I've mentioned, but I didn't mention at the start of this example, is that for this question we're only dealing with range from 0 to 360. So anything on this side of that graph is I'm not bothered with, and we're just going to go from there. Now, I'm just going to get rid of that marking because we might need it, and I'm forward thinking the fact that we will. So for the next question, if we look at the graph, we can see that where the green line, which is marked at y equals minus 9/5, that between the range of 0 to 360, I've got one interception point here and one interception point here. Now, as we said, your calculator will only give you the value that is closest to the origin. Now, the value that's closest to the first interception point that's closest to the origin is this one here. So if I type into my calculator inverse tan of 9/5, my calculator should give me that angle that is on the negative side of the y-axis. So I've got inverse tan of minus 9/5, and lo and behold, that my calculator gives me minus 60.945 with a few extra numbers. So I'm going to round this up to minus 60.9 degrees. So the first angle here, which is at minus 60.9, and what that tells me is that the distance from that point to the origin is 60.9. So to find this angle here, which is in my valid range, so we're going to label this as my second angle, that from the origin this distance here is 60.9. So to find that first angle, what I need to do is do 180 minus 60.9, and I type that into my calculator, in which I get my first valid answer of 119.1 degrees. Now I can check on my graph, does that look valid? Well, yes, because I'm looking for an answer that's bigger than 90 but smaller than 135. Now to find the third angle, which I've just labelled here, so again I'm looking at the nearest point of where it's 0, which is at 360, and it tells me that the distance from 360 to that third angle is going to be 60.9 degrees. So to find this angle, what I need to do is do 360 minus 60.9, and I type that into my calculator, in which it gives me an answer of 299.1 degrees. Now in terms of the final answer for this, although I found 3 angles, this one is not valid because it's outside the range. So not valid as outside the range, but it's worth still including in your working out because I've used that 60.9 to find my angles that are within my given range. So here x equals 119.1 degrees and 299.1 degrees. And likewise, if I just change my colour of my pen, for question A we've got x equals 68.2 degrees and 248.2 degrees. Now, this isn't the only way of finding equations. This is just the method of using the graphs. There is another way that is called cast, which I'll do another video of how we can use an alternative. So if you're not comfortable in drawing your graphs, or feel as if you're not being accurate, or it's a bit of a mess, looks like a graffiti wall, then there is another method in which you can do this. However, it is always important you understand how this works, because as a fail-safe, that if that method doesn't make sense, you can always rely back to this format. Like I said, I'll post up some questions if you'd like, so just drop me an email at 162maths@gmail.com, and if you have any of the further questions,